using the fundamental theorem of algebra. So basically the fundamental theorem of algebra states that if you have a polynomial degree n greater than 0, so the degree is bigger than 0, you get at least one complex 0. But really what this is saying is you can break it down completely. So it's completely factored and you always have x to the first powers plus or minus whatever your zeros are. Now some of these may be complex zeros, but remember, real numbers fall under complex numbers as well. There may be some number out in front here, a scalar multiple, just being a constant out in front. So let's see if we can break down one of these polynomials completely. So either we can try to pick out the zeros first by maybe using possible rational zeros, or if you can factor from the very beginning, let's just get started with that. In looking at this polynomial, degree 3, it's in descending order. I notice we have 1, 2, 3, 4 terms. So one popular technique to factor using, whenever we have 4 terms is factor by grouping. So let's group these first 2 terms together and group the last 2 terms together. Kind of say to ourselves, what do these first 2 have in common? So they have a common factor of 3 as well as x squared. So if we remove that common factor, we're going to be left with x plus 3 inside that set of parentheses. Now for factor by grouping to work, we also have to have an x plus 3 from these last 2 terms. So I'm going to say x plus 3, and then think to myself, what would need to go out in front here so that when I multiply through, we end up with positive x plus 3 as well. So in this case, it's just going to be a positive 1. That's going to be the common factor between these 2 that goes out in front. Okay, from here, let's continue our factoring. These now have a common factor of x plus 3. So let's remove that. What's going to go inside here is 3x squared plus 1 from out in front of these sets of parentheses. Okay, so we've gotten down to a quadratic, a second degree polynomial in our second set of parentheses. We may be saying to ourselves, maybe we can factor that further, but it's 2 terms, it's not a difference of squares, so that's going to be more difficult to do by hand. Instead, what I would probably do in this situation is go off to the side and say, I want to know, when does this factor equal 0? So I'm going to set it equal to 0 off to the side and try to solve this down. So I'm going to move the 1 to the other side. So 3x squared equals negative 1. Divide both sides by 3. This will create a power equation. So we have one side raised to an exponent and just a number on the other side. And now to get rid of our exponent and solve for x, we're going to apply a square root to both sides. So as we apply that square root to both sides, don't forget the plus and minus. With a little bit of simplifying down, we can say this is plus or minus. When we have that negative underneath the square root, that's equal to an imaginary number, an I. And I'm also going to bring along my square root of 1/3. Now you could do some rationalizing in the denominator here, but I'm going to leave it for the time being as this I square root of 1/3 with plus and minus out in front. So at this point, we can hopefully pick out all of our zeros. Off to the side, we just calculated these 2 to be zeros. So I'm going to go ahead and say that's negative I square root of 1/3 and positive I square root of 1/3. And then from this other factor, hopefully we're comfortable with picking out if I plugged in a negative 3 plus 3 would make this 0. So negative 3 is going to be our third 0 for this polynomial. The last thing we want to do is completely factor this. There is a trick to it though. All right, for our factors, well, the first one should be pretty obvious. The x plus 3 goes hand in hand with this 0. And then for the rest of these, just be careful that if you know a 0, you can always create a factor as using x minus whatever the 0 is. So in our case, we can say I square root of 1/3 was one of our, or negative I square root of 1/3 was a 0. So we can say x minus negative I square root of 1/3 or x plus I square root of 1/3 is going to be a factor. And then x minus I square root of 1/3 for that last 0. X minus whatever the 0 was. Now this one does have something special going on that if we were to multiply this all out, you're going to have an x times another x times a third x, but that's going to get you to x cubed. Our original starting function had 3x cubed as our highest power of x. So what we need to do is account for that 3 that's out in front. And it's going to have to go out in front of our factored version of this, so that if we were to redistribute everything, we get back to the very same as the original function that we were given here. All right, so don't forget that 3 from out in front here has to go out in front here, so that if you multiplied this all out, we'd have 3 times x times x times x to get us this 3x cubed for our first term. All right, hope this helps out. I know we ended up with 2 complex zeros and a rational zero, a real zero going on here. But just take your time, factor whenever you can. And if you need to set a factor equal to 0, solve down, go for it. This one I was able to make into a power equation. You may need to utilize the quadratic formula to help you out in finding those complex zeros. All right, good luck.